Friends, you learned in the earlier class that acids are sour in taste and bases are bitter in taste with a soapy touch. Acids turn blue litmus to red and bases turn red litmus to blue. In this video, I am going to discuss the concepts of acids and bases, a few acid-base indicators and neutralization reaction. Self-assessment quiz and other questions are included after explaining the concepts. Let us perform two experiments in order to understand the concept of an acid. Experiment 1. Conduction of electricity by dilute HCl solution. Carry out the experiment as shown in the figure 1. You see here in this beaker, dilute hydrochloric acid solution is taken. 2 iron nails are fixed to a rubber cork. The 2 iron nails are connected to the 2 terminals of a 6-volt battery. There is a bulb and also a switch in the circuit. What do you observe? Now, carry out another experiment by taking glucose solution instead of dilute HCl solution. What do you observe? With dilute HCl solution in the beaker, the bulb glows. With glucose solution in the beaker, the bulb does not glow. In the above experiment, it is inferred that HCl aqueous consists of H plus aqueous ions and Cl minus aqueous ions, which are the charge carriers in solution and responsible for conduction of electricity, and the bulb glows. Whereas glucose solution is not dissociated into ions and does not conduct electricity, the bulb does not glow. Let us do another experiment. Conduct an experiment to produce dry HCl gas by carrying out the reaction between solid NaCl and concentrated H2SO4. This dry HCl gas does not turn dry blue litmus paper to red, whereas it turns moist blue litmus paper to red. This experiment infers that when HCl gas comes into contact with moisture, that is water, it gives the test for acidic property. That means only HCl aqueous is an acid but not HCl gas. HCl aqueous solution dissociates first into H plus aqueous and Cl minus aqueous. H plus ion immediately reacts with H2O to form He3O plus, that is hydronium ion. I have given the 2 steps here. See, H plus ion here reacts with the molecule of water and produces hydronium ion He3O plus. Acids such as sulfuric acid H2SO4, nitric acid HNO3, acetic acid CH3COOH, etc. also produce hydronium ions in aqueous solution. But substances like glucose C6H12O6, methyl alcohol CH3OH, ethyl alcohol, that is C2H5OH, and many other organic substances do not produce hydrogen ions, even though they also contain hydrogen atoms. Therefore, these substances are not acids. Glucose, methyl alcohol, and ethyl alcohol and other organic substances which do not produce hydrogen ions in aqueous solution are not acids. Now let us define an acid. Acid is a substance which forms hydrogen ions H plus aqueous or hydronium ions H3O plus in aqueous solution. The above definition is according to Arrhenius theory of acids. For examples, I have given already hydrochloric acid, sulfuric acid, nitric acid and acetic acid are examples of acids. Now, let us try to understand the concept of a base. The compounds such as sodium hydroxide NaOH, potassium hydroxide KOH, calcium hydroxide CaOH twice, ammonium hydroxide NH4OH, etc. form hydroxide ions in aqueous solution. For example, you consider NaOH solid dissolved in water, it produces Na plus aqueous and OH minus aqueous ions. Some other hydroxides such as copper hydroxide, that is CuOH twice, zinc hydroxide, that is ZnOH twice, silver hydroxide AgOH, etc., which are not soluble in water, but they react with acids and release the OH minus ions. For example, CuOH twice solid plus 2HCl aqueous gives rise to CuCl2 aqueous plus 2H2O. In the above example, CuOH twice reacts with HCl aqueous and release acids OH minus ions. All the above substances release hydroxide ions, that is OH minus ions, in aqueous solution. All such substances are called bases. Now let us define a base. Base is a substance which releases hydroxide ions, that is OH minus, in aqueous solution. The above definition is according to Arrhenius theory of bases. The bases like NaOH, KOH and CaOH twice are the hydroxides of alkaline and alkaline earth metals. Therefore, these bases are called alkalis. Alkalis are soluble in water. But you look at the other bases like CuOH twice, ZnOH twice, AgOH, etc. are the hydroxides of other metals, not of alkaline or alkaline earth metals, other metals. These bases, therefore, are not called alkalis, and these bases are not soluble in water. Please know that all alkalis are bases, but all bases are not alkalis. And another point is that alcohols like methyl alcohols, that is CH3OH, ethyl alcohol, C2H5OH, glucose, C6H12O6, etc. also contain OH groups, but these do not release OH minus ions in aqueous solution. Therefore, these are not bases. Testing of acids and bases. See, we test acids and bases with indicators, which are known as acid-base indicators. Litmus is a natural acid-base indicator prepared from a plant extract. See, blue litmus and red litmus papers are used to test acids and bases. Here, you have immersed a blue litmus paper in a solution, and that blue litmus turns to red. You observe here. It infers that the solution is acidic. In this beaker, you have taken a solution and you have dipped a red litmus paper in this solution. And red litmus paper turns to blue. It infers that the solution is basic. Now, let us consider another indicator, that is phenolphthalein, which is a synthetic acid-base indicator. it is colorless. When it is added to an acid, its color does not change. It is still colorless. But when it is added to a base, its color changes to pink. You look at this figure. Now here in the left side, phenolphthalein indicator is being added. It is a colorless solution, but the color is changing to pink color. But after phenolphthalein indicator is added to completely, then the whole solution turns to pink color. It indicates that this solution is basic in nature. In acidic solutions, this phenolphthalein remains colorless, but in basic solutions, it turns to pink color. Now let us consider another acid-base indicator, that is methyl orange. It is orange in color originally, but when it is added to an acid, its color changes to red. And when it is added to a base, its color changes to yellow. Now look at this figure. See here, methyl orange is added to a solution and the color is yellow. What does it infer? The solution is basic. Now look at this. Here it is orange in color. What is the inference? It infers that the solution is neutral. But look at these solutions in the remaining 4 test tubes. See here, it is very bright red. That means acidic nature goes on increasing. So in the acidic solution, the methyl orange indicator turns to red. So by using methyl orange, you can easily test whether the solution is acidic or basic or neutral in nature. Now let us see what happens when an acid is added to water. It is called dilution of acid. For example, if you want to dilute sulfuric acid solution, this is the reaction. H2SO4 aqueous plus H2O liquid gives rise to H3O plus ions, hydronium ions, and hydrogen sulfate ions, aqueous, plus heat. Thus, dilution of an acid is an exothermic reaction. A large amount of heat is generated in this reaction. Important note. Please remember this important note, sir. Always add acid drop by drop to a large volume of water for dilution of an acid. The heat generated will be dissipated to the large volume of water and it is very safe. But if you add water to acid, the large amount of heat generated may cause the acid splash outside the beaker. Sometimes it may even break the beaker. Therefore, avoid addition of water to acid. And sometimes you do the experiments using acids. After finishing experiments with acids, do not throw the reaction mixture in the sink because the leftover acid will react with the leftover water in the sink and generate a large amount of heat, which is very, very dangerous. Now, let us see what happens when alkalis are dissolved in water. Okay, let us discuss with an example. NaOH plus H2O gives rise to Na plus aqueous plus OH minus aqueous plus heat. So this dissolution of alkalis in water is also an exothermic process. Suppose if you want to dilute sodium hydroxide concentrate, sodium hydroxide solution with water, that is also exothermic process. Now, let us discuss what happens when acids and bases react with each other. Consider a chemical reaction between sodium hydroxide solution, base, and sulfuric acid solution, which is an acid. The chemical equation is 2NaOH aqueous plus H2SO4 aqueous gives rise to Na2SO4 aqueous plus 2H2O plus heat. This is a neutralization reaction. OH minus from NaOH and He3O plus ions from H2SO4 react with each other and form water molecules. Neutralization reaction is also an exothermic reaction. In a neutralization reaction, an acid reacts with a base to form salt and water. Examples of some more neutralization reactions are given below. 2KOH plus H2SO4 gives rise to K2SO4 plus 2H2O plus heat. NaOH plus HCl gives rise to NaCl plus H2O plus heat. Now, self-assessment quiz. Which one of the following substances is not a base? Options: A. KOH, B. NaOH, C. C2H5OH, D. ZnOH twice. Choose the right option. Question 2. Which of the following statements are correct? Option 1. HCl gas is an acid. 2. HCl aqueous is an acid. 3. CH3OH is an acid. 4. CH3COOH is an acid. Options. Option A. 2 and 3 correct. B. 1 and 4 correct. C. 3 and 4 correct. D. 2 and 4 correct. Question 3. Which of the following statements are correct? Blue litmus turns to red in acidic solution. 2. Methyl orange turns to red in basic solution. 3. Phenolphthalein turns to pink in acidic solution. 4. Phenolphthalein turns to pink in basic solution. Options. Option A. 1 and 4 correct. Option B. 1 and 3 correct. Option C. 2 and 3 correct. Option D. 2 and 4 correct. Choose the right option. Now, assertion and reason type questions. Assertion. A. HCl aqueous solution conducts electricity, but glucose solution does not conduct electricity. Reason. HCl aqueous solution consists of H3O plus and Cl minus aqueous ions which are charge carriers, but glucose solution does not consist of any ions. Options. A. A is correct and R is wrong. B. A is wrong and R is correct. C. Both A and R are correct. D. Both A and R are wrong. Another question. 5. Assertion. Water is added to an acid taken in a beaker for dilution of an acid. Reason. Dilution of an acid with water is an exothermic process. Options. Option A. A is correct and R is wrong. Option B. A is wrong and R is correct. C. Both A and R are correct. D. Both A and R are wrong. Other questions. Define an acid. Give 2 examples. Define a base. Give any 2 examples. Question 3. All alkalis are bases, but all bases are not alkalis. Justify the statement with proper explanation. Define neutralization reaction. Give an example. 5. Name 2 synthetic acid-base indicators. Write their color changes in both acidic and basic solutions. Question 6. With a neat sketch, show that HCl aqueous solution conducts electricity. 7. If an acid is diluted, how is its hydronium ion concentration affected? Question 8. If some more NaOH is added to a solution of NaOH, how is its hydroxide ion concentration affected? Now, conclusion. Concepts of acids and bases and testing them use indicators are important to master the knowledge of chemistry of acids and bases. Watch the video again and again till you gain the mastery of concepts. Answer all the questions given in this video independently in your notebook. Only then you have learned the subject conceptually. The answers for all the questions prepared by you will also serve as the learning material for any examination. I wish you the best in all your efforts.